Welcome to the presentation on future research on cross-laminated timber for multi-story buildings, a questionnaire among engineers active in practice. My name is Martin Schenk. I'm Research Associate at Technical University of Munich, Germany, and I'm working together with Pablo González-Serna under the supervision of Professor José Manuel Cabrero in a work package of an international research project called InnoCrossLam. InnoCrossLam is an acronym for Innovative Solutions for Cross-Laminated Timber Structures. The project is funded under the umbrella of Forest Value and has received funding as well from the European Union's Research and Innovation Programme Horizon 2020. Now I will present you first the framework of this study. Second, we will deep dive into the results. And third, we will draw our conclusions. The background of the study is very clear. The rather young material cross-laminated timber hardly made its way into the European design standards of the first generation, the Eurocodes. Those documents developed in the early beginning of the century got now revised towards the second generation, and CLT will be profoundly integrated. But the question remains, will this cover the majority of the design situations that we find every day on site? To investigate this, we distributed a digital questionnaire on cross-laminated timber design worldwide to those practitioners which might process or install CLT. This means structural engineers, suppliers and manufacturers, and research institutions. We asked altogether 48 questions on the experience of our participants on CLT constructions, their general design methods, finite element software, and complex design situations. Where do our participants see challenges, problems, and possible improvements? Beyond that, we ask more detailed questions on joints and connections and seismic design. We started the study in January 2020, and on the cutoff date in August 2020, we received feedback from 141 participants from over 20 countries. Most of the feedback came from countries like Spain, Germany, and Austria, but we also received some replies from experts from countries like Canada, New Zealand, and Australia. Now let's deep dive into the experience of our participants on CLT constructions. The group of respondents consisted mainly of structural engineers and design companies with more than 10 years working experience. Most of the companies have more than 30 employees, and they work mainly in the timber sector. To wrap this short numbers quickly up, the present data suggest an in-deep experience of our respondents and a suitable working environment for our study. The majority of our respondents seems to be in, let's say, close contact with CLT. Nevertheless, even though the participating companies are working in the timber sector or are very active in the timber sector, CLT takes only a small percentage in the overall order volume of those companies. This suggests or this indicates a huge market potential for CLT, not only in comparison to other materials, but also within the timber sector. Single double family houses, apartment buildings, and multi-story buildings higher than 4 stories are that type of constructions where CLT seems to be used most. Last but not least, when it comes to the confidence of the participants with current design concepts, whether current design concepts are adequate, the opinion seems equally split in two. So as you can see here, nearly 50% confident, 50% not so confident. Now let's have a look how these design concepts look alike for our participating groups. The table on screen now shows tools used by the engineers divided into the branches design, construction, and research. As can be seen, no best practice solution, be it hand calculations, finite element software, or own solutions, for instance, Microsoft Excel sheets, can be identified. So no best practice solution can be identified. Rather, individual combination of those solutions is used by the participating engineers. The next question now investigated the used structural model for plates and bending. The gamma method, an equivalent beam method approximating the material behavior, is here, as you can see, in favor within the investigated groups. Asking in parallel about the inclusion of the material layering into the structural modeling, such a statement about preferred methods cannot be done, as you can see here. With 15 to 20% rather high seems the share of respondents who do not know how the layering is considered. This impression is supported by the lower number of participants who apply homogeneous cross-sections into their modeling in comparison to those who process with the gamma method. Both values should be at least equal. When asking about the implementation of the torsional stiffness into the models, only one third of their respondents indicated an absolute number. And finally asking about the applied Poisson's ratio, 45% of the participants respond not to know which value is used. But now let's move over to the topic finite element software. As we have seen before, finite elements are a proper tool for CLT processing engineers. We ask them, therefore, to name their specific program. Within the group of respondents, tools from the company Duval, as you can see here, and also tools from provided by CLT producers are in proper use. So as you can see here, for instance, Dora Enzo Calculatus and KLH Designer. The investigation showed as well that the satisfaction with those tools is rather high. And of course, the highest with those solutions that the engineers developed by some themselves. We also asked if results given by a software are verified. That at least 20% of our engineers do not verify software output. Seems to me personally frightening. When verifications are done, then mostly by hand calculations, comparison calculations in a different software, or by experience. But of course, sometimes comparison is not so easy. As already mentioned before, we investigated where design with CLT for multi-story buildings gets complex for practice. On this slide here, you can see some examples. Openings in walls and floors here, deep beams, beams with openings, point supports and concentrated loads, and cantilevers, as well as asymmetrical layups. Those would, for instance, be the case after a fire occasion. Within these examples, the participants indicated the concentrated loads and the openings in walls and floors as the most challenging. Further on, as explanation, it was clearly stated that design concepts and guidelines for those constellations are missing or incomplete. And of course, we ask our participants to provide other challenging design situations. As you can see, joints connections, vibrations, and fire design have been answered relatively often. Other mentioned categories were durability or execution rules. And again, as justification for naming them, are missing or incomplete design guidelines. Since we identified the joints and connections prior to the distribution as potential issue, we asked some more detailed questions. One of those questions was about the modeling of those connections. And as you can see here, independent of where a connection is applied within a structure, so independent if whether this would be our floor within a floor, a connection within a floor, or connection within a wall, or even a connection between a floor or wall. Engineers active in practice are mostly used to model them as springs. But when it comes to the absolute numbers of those stiffnesses, and a bandwidth cannot be given. Now let's finalize our evaluation with the design of multi-story CLT structures in seismically active areas. Approximately 40% of our participants carried out such design scenarios. They clearly prefer static methods. Static methods like the lateral force method and the modal response analysis before carrying out dynamic analysis. And also linear material models seem to be more likely to be used than nonlinear ones. When asking about reasons why CLT structures are not so common to be used in seismically active regions, again, missing standardized solutions are highlighted by the practitioners. Also, a need for education and training is deemed to have a major influence. So now, after approximately 10 minutes full of numbers and diagrams, let's draw our conclusions. Knowledge gaps exist with respect to some material parameters, for instance, the torsional stiffness of plates and banding, and the Poisson's ratio. The most challenging design situations for engineers active in practice are the point supports and concentrated loads, openings in walls and floors, and joints and connections. Beyond the ULS, the areas of vibrational behavior, durability, and execution were identified as problematic. Reasons for the challenges and difficulties are mostly missing or incomplete design guidelines and a lack of education and training. So further research in these fields actually would increase the applicability and the competitiveness of CLT with other building materials globally. So let's take that as our task. If you want to read more about CLT, I provide you here the list of literature that I used for my article. And before saying goodbye, I would like to thank the organization team of Wcte, which had a really difficult work in the last 2 years. So thank you, and thank you for your attention. In case of questions, please reach out to us. And yeah, goodbye.